In 1977, two scientists published the most complete picture of the ocean floor that had ever been created, revolutionizing our understanding of the Earth. Named the Tharp-Heezen map after its collaborators, this illustration was produced using sonar and measurements of the water's depth. It revealed, for the first time, a complex network of underwater mountains and ridges, and provided key evidence that supported the emerging geological theory of plate tectonics. This theory states that the Earth's solid outer shell, the lithosphere, is broken into plates. These plates shift and slide over the asthenosphere, the molten upper portion of the mantle. Oceanic and continental plates meet and interact at boundaries that crisscross our planet. Because 71% of the Earth is covered with water, the majority of boundaries are found on the sea floor. When two oceanic plates tear apart from each other at a divergent plate boundary, the space between the divergent plates fills with magma that hardens when exposed to cold seawater. Over millions of years, this process has built chains of underwater volcanoes and rift valleys called the mid-ocean ridge.
When the plates move apart, they rip open the Earth. The mid-ocean ridge, which runs around our planet like the seam on a baseball, is where the Earth creates its outer skin. And as these plates move, they're in a synchronized ballet.
There are few places on Earth where the mid-oceanic ridge rises out of the ocean, giving us a chance to see this phenomenon on dry land. Iceland is one of them. The island of Iceland was once an underwater section of the mid-ocean ridge. Over millions of years, it was pushed up above sea level by a giant volcanic hotspot. Here, we can see a divergent plate boundary, a stretch of the mid-Atlantic ridge where the North American and Eurasian plates are spreading or rifting apart. Geologist and oceanographer Dr. Bob Ballard has come to this unique spot where crystal-clear glacier water has filled a section of the mid-ocean ridge that has been raised above sea level.
Boy, that's truly amazing. I'm literally at the boundary of creation in Iceland. On my left is the North American plate right here. I can put my hand on North America. I can reach over here and put my hand on the Eurasian plate. And this is the very spot where the Earth is spreading open, about an inch a year, about your height in your lifetime.
When two plates are spreading apart in one section of the world, other plates are moving toward each other in a different area, forming a convergent plate boundary. At these kinds of plate boundaries, one plate can slide underneath the other in a process called subduction. Or the two plates can crash into each other, creating a mountain range. The Himalayan mountains formed this way when two continental plates collided. On the Mediterranean island of Cyprus, we find an example of a convergent plate boundary that was raised above sea level 90 million years ago as the African and Eurasian plates collided. Dr. Ballard has come to explore this unique part of the mid-ocean ridge in the light of day.
I'm standing on what was an ancient ocean floor, would have been thousands of feet beneath the sea, and what we're looking at is an area where the subsequent collision of these great plates, the African plate and the Eurasian plate, then began to force this part of the ocean floor up to where it is today.
This upward movement revealed ancient volcanic activity that had taken place on the ocean floor.
If you look into that upper section, you'll see these round-looking objects, and those are actually what we call the pillow lavas, because as the lava comes out, and no sooner does it come out, it's quenched. And then it expands and continues to quench and forms these pillow-shaped forms, and then it'll pop out, form another one, pop out, form another one. So you can literally see all these different areas in which the molten lava actually expanded out and then cooled.
The study of plate tectonics from the tallest mountains to the bottom of the ocean, helps scientists understand the extraordinary processes that continually shape and reshape our planet, sculpting majestic landscapes, causing earthquakes and volcanoes, and supplying natural resources.